Once you have started the software, click on the new project, give the appropriate name for the new project, set the proper units and press OK. The next step is usually to set the material properties. Open the new material dialog box, define a new material name, enter the values and press OK. The first construction step for modeling a planar structure is usually to define the substrate layer. This can be easily achieved by creating a brick made up of substrates material in the box geometry section. The material setting of the brick must be changed to the desired substrate material. Now provide the various values like x1, y1, z1, x-axis, y-axis, z-axis values. Select the material as new material and press OK. The next step is to model the microstripline metallization on top of the substrate. Therefore, you should again do the same process. For the dimensions of the microstripline over substrate, you should design the microstripline. So provide its x1, y1, x-axis values, y-axis values, z-axis values. Select the material as PEC and press OK. The next step is to model the ground plane below the substrate. Therefore, you should again do the same process. For the dimensions of the ground plane below the substrate, you should design the ground plane brick. The material setting of the brick must be changed to the desired ground plane. Provide the values for x1, y1, z1, x-axis, y-axis, z-axis. Select the material. In this case, it has to be PEC and press OK. The next step is to add the ports. We need to add the ports to the microstripline device, for which the S parameters will later be calculated. Each port will simulate microstripline structure that is connected to the structure at the ports plane. Plane wave ports are the most accurate way to calculate the S parameters of the microstrip devices and should thus be used here. We need to provide the various values like x1, y1, z1, x2, y2, z2, ports impedance, deimpeding distance, and press OK. Similarly, for the port 2, we need to give the name as port 2 and then define the coordinates as we defined previously. That is, we need to provide the values for x1, y1, z1, x2, y2, z2, post parameter values, and press OK. Now we need to provide the value for the Z max for the surrounding space. After doing this, we need to provide the value for Z min in the boundary condition setup box and press OK. Now go to the probes and choose EM field visualization and enter 1.5 GHz as frequency. Once we have done this, next step is the solver settings. For this, go to the solver. By pressing the setup button, a dialog box will open. Provide the various settings as per the formula. You need to provide the frequency settings, and once you've provided all the settings, press OK. Now we will save the project by providing it a name. In this case, we will provide it the name as Microstripline. Once we have saved the project, now finally we can start the simulation by going to the solver and press the simulation button. A progress bar will appear in the status bar, displaying some information about the solver setting. Now let's review the results.